Hey, MathCook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathcook.com. Let's MathCook it up. This question says, Anthony is standing at one of the foci of a semi-elliptical tunnel 104 feet in length. His bestie, LeBron, wants to stand at the other focus. So if Anthony whispers, only LeBron can hear. The height of the tunnel at its center is 20 feet. Where should LeBron stand? Okay, so let's draw a picture of this semi-elliptical tunnel. So it's going to be an upside down. So we'll do a point here, a point here, and a point here. It's going to be like an upside down ellipse. Go like this here. All right, so there's our tunnel. And notice they tell us it's 104 feet in length. So I'm going to go ahead and draw that here. So this length here is 104 feet. So we got that. His bestie LeBron wants to stand. Okay, so there's two foci here. So we'll go ahead and draw those. I'll do those in red. And we have Anthony standing over here. So we'll say there's Anthony. Then we have LeBron standing over here. So there's Mr. LeBron. So we need to determine where LeBron needs to stand in order to hear Anthony whisper. So that distance right here is going to be the distance from the center, 0, 0, which, remember, LeBron is standing at the focus. So the distance that we're trying to find in this problem is C, because that is the distance from the center to the focus. So that's what they're asking for. Okay, so what else do we know? Well, we know the distance from the center, 0, 0 here, to the vertex, because the distance, 104, represents the length of the major axis here, which is really 2a. So if we split that in half, we can get a, which is the distance from the center to the vertex. So 104 divided by 2 is 52. So that tells us that a equals 52, and that's this distance right here. All right, so now we have our a value, and they also tell us that the height of the tunnel at its center is 20 feet. So that means this distance from here to here is 20 feet. So I'm going to go ahead and label that as well. So our height here is 20 feet. So that is going to be B, 20 feet. All right. So B is the distance from the center to the co-vertex here. All right, and then what are they asking for? So that where should LeBron stand? So remember, we're trying to find C. So is there an equation that relates A, B, and C for an ellipse? Yes, there is. Here it is here. C squared equals A squared minus B squared. So let's go ahead and plug in, and we can find out what C is. So C squared equals then A squared, so 52 squared minus B squared. So that's 20 squared. All right, so C squared, if we do this on our calculator, 52 squared will give us 27 over 4 minus 20 squared, which is 400. And if we subtract those, we will get 23 over 4. And then we take the square root, both those numbers, and then we only care about the positive one, even though when you take the square root, you should get plus or minus, but we only care about the positive value. We get 48. So C equals 48 feet. So that tells us that LeBron should stand 48 feet from the center of the tunnel. So right here, so this distance right here is 48. Now another way he could do this is he could go walk to the very end here and go backwards. So remember, if he walked from the center of the room to the edge here, it would be 52 feet. So really, he just has to stand 4 feet, because 52 minus 48 would be 4 feet. So I'll mark that on here. So if you just march back 4 feet from the edge of the tunnel here, not that he could fit because it goes down to nothing here, but if he measured 4 feet from the right side of the tunnel, that's where he would need to stand in order to hear Anthony's voice bounce off the tunnel here. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.